Hey there, welcome back. So in the previous video, I've given you an introduction to PyTorch tensors, and I've also seen like what are the different methods in which you can create tensors, and you have also seen, like what is the default data type of PyTorch, what are the different data types which are available in PyTorch and so on. And in this video, what we are going to do is we'll see what different operations you can perform on top of tensors, right? So let's get started. So here, as you can see, we have the same Jupyter Notebook PyTorch tensors demo, and I've also written all the code that we are going to execute in this video, and the reason is just to save your time and my time as well, right? So here you have all the code, and now what I'll do is I'll just run through this code one by one, and I will also explain what they do, right? So starting off with line 1, so here I'm just printing the value of tensor1. Now tensor1 is a tensor that we created in the last video, so hopefully it's still there in memory. So here is our tensor1. So it's basically a 2D tensor. The first row contains 1, 2, 3. The second row contains 4, 5, 6. So now let us create another tensor which is like our tensor1. So that tensor should have the same shape as tensor1, but it will contain only ones. Now that we will do using the ones like function. So now you have tensor2. Now say you have a problem that you would like to merge these tensors row wise and get a new tensor. Now if you want to do something like that, then the function that you are going to use is called cat. So this torch.cat will basically concatenate these two tensors, and it will return you a resultant tensor pretty much like this. Now this, in this way you can see that the first tensor 1, 2, 3, 4, 5, 6 is over here, and the second tensor, which is 1, 1, 1, 1, 1, this is over here. Now there is also another way in which you can concatenate these tensors. So for example, here what you can do is you can pass another parameter which is dim equals 1. Now this I will just name it, say call, and if I run it, you can see now the concatenation happened column wise, right? So first you have this first tensor, right? 1, 2, 3, 4, 5, 6, and then 3 more columns were added, and the number of rows are same, and in those columns you have 1, 1, 1, 1. So this is a function in which you can concatenate two tensors either row wise or column wise based on the dimension parameter, right? So now let's see, you want to do something opposite of concatenating tensors. So now you have a huge tensor, for example say this tensor. So you have a tensor of 4 rows and 3 columns, and now you would like to get 4 different tensors out of it. How will you do that? Now in such a scenario, you can use a function called the unbind function of PyTorch. So here we have torch.unbind, and here we are passing tensor cat, which is our concatenated tensor, and we are also passing the dimension as 0, since we want to divide this tensor row wise. So the first tensor should contain this row, the second tensor should contain this row, and so on. And now if I run it, you can see that it returns a tuple of 4 different tensors. So it basically broke that single tensor into 4 different parts, and it returned 4 tensors. Now this same operation you can also do column wise if you pass the dim value as 1. So if I just execute it, you can see that now we have 3 different tensors, since we have 3 columns, and in each tensor we have the column values. For example, the first tensor contains 1, 4, 1 and 1, right? This is pretty much the value of the first tensor, and similarly you have the other 2 tensors as well. Now there is also another function which also does similar things, and that function is called torch.chunk. So here what I do is I'll just call torch.chunk, and I will pass the tensor that we want to chunk. So we have tensor cat over here, and then you need to pass the number of chunks you need. So by chunks it means that the number of tensors you need out of this parent tensor, which is tensor cat. So here I've passed 2, which means that you break this tensor cat into 2 different tensors and return me, right? So here we have tensors cat. I have specified the number of chunks to be 2, and I've specified the dimension to be 0. Now if I execute it, you will see that we have 2 different tensors. Now you might ask a question that what is the point of having torch.chunk? Since we already have torch.unbind, right? Then why do we need to chunk the tensors again? Now the reason of torch.chunk is that torch.unbind will unbind the tensor, right? It will break the tensors into chunks, but it will also reduce the dimension of the tensor. So here you can see, right, when we executed unbind, then initially we had a 2D tensor, right, but after unbinding we have 4 1D tensors. And similar, like whenever we even unbind in column wise, then also we have 3 1D tensors. So it not only unbinds the tensor, it also reduces one dimension. But in case of chunk, you can see that the chunks we got, right, we got 2 chunks over here. Now both of those chunks are 2D tensors. So like similar to unbind, you can also execute torch.chunk column wise. So in that case, you, like as you have guessed, that we just need to pass the dimension parameter as 1. So if we do that, then we again get 2 chunks. So the first chunk contains 4 rows and 2 columns, and the second chunk contains 4 rows and 1 column. Now we are pretty much done with the unbinding, chunking and all these things. So now let us go through some mathematical functions which are offered on top of tensors. So again, we have our tensor 1, which contains 1 2 3 4 5 6. So now let us try to add a value to this tensor. So basically we are passing the value 10, and what we want is that once we basically want 10 to be added to all the values in the tensor. So after addition, it should be 11 12 13, like that. So if I execute it, you can see that it happened. So we have 11 12 13 14 15 and 16, right? So this is one such a function using which you can do that. But in the next term, if I print tensor 1 again, you can see tensor 1 is still containing 1 2 3 and 4 5 6. And the reason is because when you call this add function over here and you pass in some value, now instead of add you can even call mul or subtract or something like that. Now what those functions does is those will add the value that you have passed to all the values in the tensor, and then they will return a new tensor. So they won't really manipulate the the memory, like where the tensor is stored. Or let me just rephrase it in a way. So basically this function is not an in place function, right? So it will create a new tensor, and in that tensor it will have all the values the way you need it. So if you want to use this function, you basically have to store the value in tensor 1. So it will be pretty much like this. And let us not do it now, because there are also some other functions using which we can pretty much achieve the same thing. And I will just write Ctrl Z. Yeah. Okay, now coming to the in place functions which we have. So similar to normal add, we also have add underscore. Now if we execute add underscore, and you can see that after that I'm trying to print tensor 1. So if I execute it, you can see now tensor 1 contains all these added values, right? So this is an in place function, and it will be like the 10 will be added to the same tensor. It won't return you another tensor. Similarly, we also have sub for subtracting 5. Then we also have a function called square root, right? So these are pretty much the different mathematical functions you have. There's also mul, and there are a lot of functions available, and you can easily check them out in the PyTorch documentation. Now let us create another random tensor to do some more operations. So this random tensor contains is of the shape 3 by 3, and it contains some values between 0 and 1. So now say if you want to know what are the total number of elements stored in your entire tensor. So you can have a 2 by 2 tensor or a 3 by 3 tensor or anything, right? But what is the total number of elements stored in the tensor? That you can do by calling this function called torch.numal. Now what numal stands for? It stands for number of elements. So it is torch.numal. You pass the tensor, and if I execute it, you can see the value is 9, since in this tensor you have a total of 9 different values stored, right? There's also a function in PyTorch called the size function, which is available for all the tensors to see the size of the tensor. So for tensor rand, if I execute this, you can see that the size is 3, 3. So yeah, these are pretty much like how you know the shape of the tensor and the number of elements and so on. Now coming to the views, right? So by views, you would already know, as I believe that you have worked on NumPy. So in NumPy we have views, right? So the ND arrays that we have, we can slice in that in those ND arrays, and view the ND arrays in different shapes and all those things, right? And those are things which we can also do in PyTorch. So here we have the random tensor which we created, and now let us execute some of those slicing and view operations one by one and see how they work. So here we again have tensor 1, and we can see we are slicing the rows from 0 to 2, which basically means it will display the first 2 rows, and then starting from column number 2, we are, I should say, starting from column index number 1, we will see all the columns. So if I execute it, you will see that again we are seeing the first 2 rows and the second and the last column values, right? So pretty much we can also do it like this. So we'll see all the rows starting from the second row, and this will basically print all the columns. And then you can also, you know, view the tensors in different shapes. So here you can see that tensor ran dot view, and I've passed the value 9 over here. So if I execute it, you will see an 1D tensor being created. So this is a 2D tensor, right? Each row contains 3 different values, and now it has clubbed all of them together into a 1D tensor, and that tensor has 9 values. But say now I write a function like tensor ran dot view, and I pass in the value 6. Now this is going to throw me an error, since the total number of elements in this tensor is greater than 6, right? So the total number of elements in this tensor is 9, and that's why I'm getting this error that you know, torch.view of 6 is not satisfied since 6 is less than 9. I mean, 6 can't also be greater than 9. So if I pass 12 here, that is also not possible. You need to pass the total number of elements, right, to do it. There's also another way in which you can view. For example, we have a 2D tensor over here. You can even make it a 3D tensor, right? So here I've specified 3, 3, 1. So if I execute it, you have this, right? So just remember that, you know, whatever values you pass inside the view function, the multiplication of all those values should return the should be the same, right? So basically here the size of this tensor is 3, 3. Now 3 into 3 is 9. So we had specified 9 over here, that was satisfied, but this was not satisfied. Here it's 3 into 3 into 1. So the total is 9. Again, it's satisfied. So we were able to view it in a different shape. So now let us try a couple of other functions, you know, which you would have also worked on in NumPy, which is like unsqueezing and squeezing functions, you know, to add or remove the dimensions in a tensor. So first what we will do is we'll create a one-dimensional tensor. So this is the one-dimensional tensor. So it contains only values 1, 2, 3. And now say you want to, you know, add a dimension to this tensor. How will you do that? So the way you can do it is basically by calling this function torch.unsqueeze, and here you will pass the tensor 1D and the number of dimensions you want to add. So if I execute it, you can see that this just became a 2D tensor now, and in each row you have just one value, right? So this is one such a function in which you can add more dimensions to your tensors. So now the thing is, for example, you have this 1D tensor. Now what would happen if you pass here 2, right? So here you just added one dimension. What if I add here 2, and because for example I want to add another dimension here and so on. So if I do that, you would see that this is not going to work since the dimension is out of range. Now why? So if you look at this, right, this is 1, right? There is just one value over here. So if you create another tensor, what will it contain? Because you already have the container, right, the outside container, and it contains these 3 values over here, right? So it's a 2D tensor now. Now if it has to be a 3D tensor, then it should be, you know, something like a list, right? Instead of 1, there should have been 1, 4 or something like that. So all the values should have, you know, it should have been a list. Rather you just have one value, so it's not possible to unsqueeze it anymore, and that's why you got this dimension out of range error. Now let us take another tensor as an example. So here we have tensor 2D. It contains 2 rows. Each row, you know, the first row contains 1 and 2, the second row contains 3 and 4. And now say we are trying to unsqueeze this tensor, you know, to one level. So what will happen if we run it? And we can see that it just added one dimension over here. And now you can see that the inner tensor, like, you know, these are basically 2 values in both the cases. So now if we try to unsqueeze it with the value 2, you will see that now it is possible since it's a list. So it will again break this innermost list into 2 parts. And here we have a 3-dimensional tensor, right? You have, you know, 1, 2, and then you have 3 and 4 over here. And similarly, if you try to do it using 3 dimensions and so on, you'll get the same previous error which we got. Now similar to unsqueeze, we also have squeeze function, right? So if you execute squeeze on top of the tensor unsqueeze with 1, it will just remove 1 dimension. Similarly, if you do it for 2, it will remove 2 dimensions, right? So these are the different unsqueeze and squeeze functions which are available to us in PyTorch. Now there is also another function which we might require sometimes, and that is the transpose function. Now again, you already know what is a transpose, right, from matrix operations and all that. Now in Torch, so basically to transpose any 2D tensor or 3D, 4D, any tensor you can transpose. So what you have to do is you need to call the torch.transpose function, and within that you pass the tensor you would like to transpose. Then you need to pass 2 dimensions. So here the dimension 0 is 0 and the dimension 1 is 1. So before doing that, let us just print the tensor 2D and see what it contains. So the tensor 2D in the first row has 1, 2, second row has 3, 4. After we do transpose, the first row contains 1, 3 and the second row contains 2, 4. So these are pretty much all the operations you can do on top of tensors. There are many more, but these are the important ones that we are going to need throughout the course. And in the next video, what we will do is we'll see some more functions that you can run on top of tensors, and you'll also see some of the matrix operations you can do on top of tensors, since those are really important in case of neural networks. So that's pretty much it for this video, and I will see you in the next one.